Hello, in the next few minutes I will try to explain how to analyze conditional statements, and as part of this we will also cover what does converse, inverse, contrapositive, definition and biconditional statements mean. Okay, with that let's get started. So let's first look at a conditional statement. So in the following examples, let's try to identify what's the condition or a hypothesis and what's the conclusion in the statement. So let's look at the first one. All 90-degree angles are right angles. Okay, so in this, what's the condition here? Feels like the condition is angle equals, oops, sorry about that. Okay, so angle equals 90 degree seems like the condition. And the conclusion is, if angle is 90 degrees, then it's a right angle. Fair enough? Seems pretty simple, but as you will see in the next few minutes, this becomes very important. Okay, let's look at the second one. 2x plus 7 equals to 1 because x is equal to minus 3. So this is very self-explanatory. Condition is if or when x is minus 3, the conclusion is 2x plus 7, the value will be 1, right? The third one, again, pretty simple. When n is equal to 9, n square is 81. So the condition is if and when n is 9, if or when n is 9, n square is 81. That's the conclusion. Fourth, let's look at this one. Tourists at the Alamo are in Texas, right? So here the condition is a tourist T is in Alamo, right? So that's the condition. If this condition is satisfied, then obviously since Alamo is in Texas, the tourist is in Texas. So that's the conclusion, right? So now we want to write this in the if-then form. So now it becomes very simple. Now that you have identified the condition and conclusion, I'm not going to write it, but I'm just going to read it. So if angle is 90 degrees, then angle is a right angle. So that's the first one. The second one is if x is equal to minus 3, then angle, then 2x plus 7 equals to 1. So that's the second if-then form. The next one is if n is equal to 9, then n square is equal to 81. The last one is if a tourist is in Alamo, then the tourist is in Texas, right? So that's the that's how you can convert a conditional statement into an if-then form. So now we will understand like why is this important, okay? Very soon it will be pretty obvious, but bear with me for a few more minutes. So let's look at some examples. Rewrite the conditional statement here in an if-then form. Just a few more examples. I'm not going to write it, I'm just going to state it. When x is equal to 6, x square is 36. So this becomes if if x is 6, then x square is equal to 36. I'll just write here once for the sake of it. If x is 6, then x square is 36. The next one is the measure of straight angle is 180 degrees. So in the if-then condition, we write if angle is 180 degrees, then it's a straight angle. Okay. And the last one, only people who are registered are allowed to vote. So the condition is people who are registered. So basically we say if people are registered, blah, 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 then they are allowed to vote. Make sense? So if then, that's the idea. If identify a condition, then a conclusion. Okay, let's move on. Now what's negation? The negation of a statement is the opposite of the original statement. So for example, if the original statement is the number is prime, then the negation is the number is not prime. You just make it opposite. Another statement example is the number is not even, then the opposite of that is the negation is the number is even, right? So now this sounds very simple, but this will be useful in the next few little bit confusing concepts. So let me explain that very carefully. So this concept is very important now. Converse. Now how do you write a converse? To write the converse of a conditional statement, you just need to exchange the hypothesis, or in other words, hypothesis, think about this as condition. The hypothesis, which is condition, and the conclusion. So let's look at this conditional statement here. I'll explain this better. If angle x is equal to 99 degrees, then angle x is obtuse. So in this picture here, angle x is 99 degrees. So here the condition is angle x is equal to 99 degrees, correct? This is the condition. And angle x is obtuse, this is the conclusion. Okay. So what it's saying is, in this conditional statement, if we exchange these two guys, the condition and the conclusion, then it becomes converse. So essentially, if you exchange it, then the way you have to write this is, the conclusion was angle is obtuse. So now you write, if angle x is obtuse, then angle x is 99. So this becomes the converse of this conditional statement, right? So now let's see if this converse is true, right? If angle x is obtuse, so pick any obtuse angle. If you remember, any angle between 90 degrees to 180 degrees. So let's pick, let's say 120 degrees, right? So definitely, if angle x is 120 degrees, obviously it's an obtuse. So if angle x is obtuse, it satisfies. X is 120 degrees, put it here. So angle x is equal to 120 degrees is obtuse. So this is fine. Then angle x is 99. That basically contradicts here. So it's saying that every angle x that is an obtuse angle, it has to be 99. That can't be true. We just saw that angle x is 120 degrees, or even for that matter 100 degrees, or 91 degrees, or 179 degrees as an example. There are many angles that are obtuse but are not 99, right? So basically this converse is false. That's what we are trying to prove here. So if you just write a converse of this conditional statement, if angle x is obtuse, then angle x has to be 99. That is not true. So it's false. The converse is false. Now we will see in some certain situations, in a few minutes, we will see that the conditional statement and converse can be true in certain conditions. And there is a unique meaning and importance associated when that happens. So bear with me for a few more minutes until that happens. Okay, so now hopefully you understand the concept of converse. Let's move on to the next. Actually, there are a few examples. Okay, so write the converse of each true statement. Each of this statement is true, so we don't have to verify that. We just need to write the converse of this true statement. Then we have to find out to tell whether the converse is true. Okay, so basically we have to figure out, write the converse. So first step is write the converse. Second step is figure out if it is true. If it is false, we have to explain why. So let's look at this one. If x is greater than 4, x is greater than 0. So this is a true statement. So the converse, the way we have to write it down is, if x is greater than 0, right? We have to switch. This goes here and this goes here to write a converse. So if x is greater than 0, then x is greater than 4. Let's see. So this is the converse statement. We said it, the first one is done. Now let's see if this converse statement is true. So what I would recommend is build a small table here, right? Okay, so here is the value of x, and then here we will figure out the condition, and then here we will write whether it is true or false. So if x is greater than 0, it has to be greater than 0, right? So let's pick 1. Then let's pick 5. If x is greater than 0, I'm just picking a number 5, then x is greater than 4. Okay, so 5 is greater than 4. So this condition is satisfied, so this is true. Good. If I pick as x is equal to 10, again 10 is greater than 4, so again this is true. But what if I pick x is equal to 3? Now look, 3 is greater than 0, so this is good, but 3 greater than 4, is that true? That's not true, so this becomes false. Now all you need is one false situation, and the moment that is false, this converse becomes false. So because this is not true in all situations, right? So as we proved here, when x is equal to 3, the converse is false. And that's what we figured out, and the explanation is that for the values of x is equal to actually 1, 2, and 3, this condition is not satisfied, and hence the converse is false. Okay. So now let's look at the next one. If x is less than 6, then minus x is less than minus 6. So to write the converse, we need to exchange these two guys. So if minus x is greater than minus 6, then x is less than 6. Okay, so let's again, so this is the converse statement. Now let's try to figure out if it is true or false. So for simplicity's sake, I'm going to write x, I'm going to write minus x as well, okay, and then the condition. Okay, so what is it? Minus x has to be, let's pick x is equal to 0 as an example. So minus x is also 0, right? So minus of x has to be greater than minus 6, which is true, right? 0 is greater than minus 6, right? So this condition is accurate if condition is satisfied. Now we have to see if then condition is satisfied. Then 0 has to be less than 6, which is true. 0 is less than 6, so this is satisfied, true. So now let's pick x is equal to 1. So when x is 1, this becomes minus 1. So minus 1 is definitely greater than minus 6. So this is true. So the if condition is true. So now let's see this guy. So x is 1. So the condition is 1 less than 6, which is again true, right? So 1 less than 6, that is true. So we can continue this. Maybe we pick x is equal to 5, right? So x is equal to 5. So when x is 5, this becomes minus 5. So minus 5 greater than minus 6, which is still true. And now let's look at this one. Then 5 is less than 6. 5 is less than 6. This is also true. 5 is less than 6. So far so good. Now what if we pick x is equal to minus 1? Okay, x is equal to minus 1. So when x is equal to minus 1, what does this become? Minus of minus is plus 1. So plus 1 is greater than minus 6. Definitely. This is true. Now let us look at this guy. When x is equal to minus 1, so let's put this here. So minus 1 is less than 6. So minus 1 is less than 6. This is also true. So now let's look at x is equal to maybe 7. So, but when you put x is equal to 7, this becomes minus 7 greater than minus 6. Now this is not true. The if condition is not true. So we cannot take this value x is equal to 7, because whatever value of x we take has to satisfy this. Okay. So basically we can't go beyond 6. So it looks like we tried pretty much 0, positive numbers, negative numbers. It's always true, right? So which means that this converse is true. So hopefully this is making sense now. There's a conditional statement given. We first write the converse, and then we figure out the various, we are testing for the various values of x where the converse is true or false. Even if we find one situation where it is false, it would mean that the converse is false, which means it is not true all the time. Okay, I will skip this problem. We'll move on in the interest of time. Okay, so let's look at another concept called inverse. To write the inverse of a conditional statement, negate both the hypothesis and the conclusion. So what this means is, if the conditional statement says if angle x is equal to 99 degrees, then angle x is obtuse. Then the inverse of this is basically negate this condition and the conclusion. So if angle x is not equal to 99, so here it was equal to 99, so we are now saying not equal to 99, then angle x is not obtuse. So let's see if this is true or false. So if angle x is not equal to 99, so let's pick 30 degrees. That is not equal to 99, correct? So this satisfies this condition, not equal to 99. Then angle x is not obtuse angle. Is 30 degree an obtuse angle? No, it's not an obtuse angle. This is not obtuse angle. So this is true for this angle. But what if we pick something different, which is let's say now not obtuse means it's an acute angle, right? Which is, you know, less than 90 degrees. So now so this was true. So now let's pick an example of 100 degrees. Now 100 degrees is not equal to 99, so the if condition is accurate. Now let's evaluate this guy. 100 angle 100 degrees is not obtuse. Is this true? Now, what is the definition of obtuse angle? Something that's between 90 degrees to 180 degrees. Definitely 100 degrees falls between 90 degrees to 180 degrees. So the statement that 100 degree angle is not obtuse is false. So basically this inverse condition situation is false. So just to summarize, if you are given a conditional statement and you are asked to write an inverse statement, you have to negate both the condition and the conclusion. And we did that, and then we evaluated if it is always true or false sometimes. And we found out that it is false actually. So that was inverse. And then the next concept is contrapositive. Okay. So to write the contrapositive of a conditional statement, this is a typo here. Should be contrapositive. Okay, to write the contrapositive of a conditional statement, first write the converse and then negate both the hypothesis and the conclusion. So let me explain. It's a two-step process. The conditional statement says if angle x is 99 degrees, angle x is obtuse. Pretty simple. First write the converse. Now how do you write the converse? We basically switch this, right? Don't confuse converse with inverse. Converse, we are switching this. Converse, if angle x is obtuse, then angle x is 99. So this is converse. Now contrapositive is you negate this guy as well as this guy. So contrapositive is if angle x is not obtuse, then angle x is not 99. So that's how you come up with the contrapositive. Now let's evaluate if this is true all the times, or maybe we can find that it is actually false in some situations. So now let's first focus on if angle x is not obtuse. Not obtuse means what? Either it's an acute angle, which means it has to be between 0 to 90 degrees, right? It has to be, it has to be an acute angle. So I'm just gonna write it here, acute. Or it has to be a straight angle, which is 180 degrees. What it cannot be is something between 90 and 180, right? Okay, so this is the condition. Then the angle is not 99. Okay, so let's pick any angle between 0 to 90. Let's pick 80 degrees or 30 degrees. 80 degrees is not 99, 30 degrees is not 99. Same thing holds for 1 degree or 89 degrees as well. It's not 99. So all these conditions are true so far. What if I pick a straight angle of 180 degrees? 180 degrees is not 90. This might sound very obvious, but this is how this has to be evaluated. 180 degrees not 99, so this is also true. So all the contrapositive conditions are true in this case. So that's the idea. So just to summarize, how do you create a contrapositive statement? First you find the converse. And how do you find converse? You basically switch the condition and the conclusion. And then to create a contrapositive statement, you basically negate the condition and the conclusion in this converse statement as written here. And then you test it out. And in our case, in this example, all of them came out to be true. Okay. So now let's just summarize all these concepts, okay, in one shot. Conditional statement we evaluated was if angle x is 99 degrees, then angle x is obtuse. We found all of the conditions are true. Converse, we are basically switching them, this and this. And once we switched, we found out that it is false in some situations. Inverse, basically we are negating both the condition and the conclusion in the original conditional statement, as you can see here. And again, we found out that in some situations this was false. Contrapositive, what we do is first step is to do the converse and then do basically an inverse of this converse. So negate this guy and this guy. That's how we ended up with contrapositive. And we found out that in all conditions it is true. Okay. All right. So let's move on to the next concept, which is a definition. A statement is a definition if the conditional statement and its converse are true. So if the conditional statement and the converse here, In our example previously, conditional statement was true, but the converse was false. However, in some rare situations, the conditional statement and the converse can be true. And when that is true, it's called a definition. So let's look at an example now. Conditional statement says if two lines are perpendicular to form a right angle, as you can see in this picture, two lines are perpendicular to form a right angle, then they are perpendicular lines, as you can see here. The converse of this is basically how do you create a converse? Oops. How do we create a converse? We create a converse by switching these two things. So if two lines are perpendicular lines, then they form a right angle, right? So, I mean, if you look at it, both the conditions are true here. If two lines are perpendicular to form a right angle, so this is a right angle, right? This guy, 90 degrees, then they are perpendicular lines. And what we are saying is that if two lines are perpendicular lines, then they form a right angle. So since both the conditions are true, this is a definition, right? And in such situations, when this conditional statement and converse are true, you can write them as a biconditional statement. And in a biconditional statement, this is important. You can use if and only if. So an example of the biconditional statement here is two lines are perpendicular if and only if they form a right angle. So to summarize, when the conditional statement and its converse are true, okay, it's called a definition. And you can write the definition as a biconditional statement. In a biconditional statement, you use if and only if phrase. All right. So that's what a definition means, and that's what a biconditional statement means. So let's look at some examples, and then we'll wrap up this specific topic. So here the example, rewrite the definition below as a conditional statement. Okay. So let's look at this. An angle with a measure between 90 and 180 degree is called obtuse. Okay. So basically, the way to think about this is, if an angle, so first thing I would write is if an angle is between 90 degrees and 180 degrees, it is obtuse. Then it is obtuse. Sorry, I'm writing it as in an if then. It is obtuse, right? So now what do you do? Now we have it in if and then format. So now you exchange these two to create a converse. So now the converse statement is if angle is obtuse, it is between 90 degrees, pardon my handwriting, but I think you get the gist of it, between 90 degrees and 180 degrees. So this is the converse statement. So now if you want to write that, since this and this, they both are true, so let's write the definition as a biconditional statement. A biconditional statement, the way you would write this is an angle is obtuse if, this is the key, if and only if the angle is between, the rest of the phrase here, 90 degrees and 180 degrees. I hope you got the idea of this. So first we are converting the statement into an if then, and then we are writing the converse, and then we are reconstructing the converse by using the phrase if and only if. And this final thing becomes a biconditional statement. Okay. Okay, hopefully this was helpful. I know the space is limited here. Now let's look at the next one. Coplanar points are points that lie in the same plane. So if you remember coplanar planes, if this is a plane and these are some points, they lie, all of them lie in the same plane. Think of a floor and you put some toys on the floor. All the toys are can be called as coplanar points because they are all lying on the same plane. However, if you put a toy on the floor and something on the ceiling, then those 2 points are not coplanar because they are not in the same plane. Okay, that was just a refresher on what coplanar means. Okay, how do you write it in an if and only if statement? Coplanar points are points if and only if they lie in the same plane, right? Coplanar points are points if and only if they lie in the same plane. So that will give us a biconditional statement. Similarly, let's look at the last one. If the sides of a triangle are all the same length, the triangle is equilateral. So we can write in a biconditional statement as a triangle is an equilateral triangle if and only if all sides are of same length. So that's how you would write the biconditional statement. Hopefully this was helpful. We covered quite a few topics in this session. I know some of them might be confusing, but hopefully this clarified and helped you. We covered conditional statements, converse, inverse, contrapositive, definition, and biconditional statement. Thank you so much for taking the time. Bye.